So now our next part is uh, x differentiate x square plus 1 divided by x square minus 1 with respect to x minus 1 over x plus 1. Exactly the same procedure by naming first y and u and differentiating this one and this one separately, and then we have to find the required derivative, which will actually be dy by du if we named it y and it will be u. First, we calculate derivative of u with respect to x. So giving a name to x minus 1 over x plus 1 to u. So differentiate with respect to x du by dx. We have here d by dx of x minus 1 and x plus 1. By using quotient theorem, a simple thing, x plus 1 whole square and x plus 1 will be as it is, and derivative of numerator, which is x minus 1, minus x minus 1 will be as it is, and derivative of x plus 1. So this one is x plus 1 as it is, and derivative of x minus 1 is 1. And this x minus 1 will be as it is, and derivative of x plus 1 is also a 1. Actually that is a, here we have x plus 1 and derivative of x minus 1 is 1, because derivative of 1 will be 0, minus, and here we have x minus 1 as it is, and derivative of x plus 1, derivative of x will be 1 and derivative of 1 will be 0, so again we have 1 whole divided by x plus 1 whole square. So simplifying this one, this x plus 1 will be multiplied by 1 will become x plus 1, and this minus will be applied on this x minus 1. So we have minus x, and this minus and minus will become plus 1, and this x will be cancelled out. We have 2 divided by, this is actually 2 divided by x plus 1 whole square. Now let y is equal to x square plus 1 divided by x square minus 1. Differentiate with respect to x by applying quotient theorem. We have x square minus 1 whole square, and in numerator x square minus 1 will be as it is, derivative will apply on x square plus 1, and next x square plus 1 will be as it is, and derivative will apply on x square minus 1. So applying derivatives, x square minus 1 will be as it is, and derivative of this function will become 2x, because derivative of 1 will be 0, and minus x square plus 1 as it is, and derivative of x square minus 1 will be 2x, and this denominator is as it is. 2x will be the common factor from both of these two terms, so the remaining portion will be x square minus 1 and minus x square minus 1, and this x square will be cancelled out. We have by cancelling this x square, we have minus 2x divided by x square minus 1 whole square. So our required dy by dx will be minus 4x divided by x square minus 1 whole square. Again by using chain rule, dy by du, that is equal to dy by dx into dx by du, and dy by dx is minus 4x divided by x square minus 1 whole square into dx by du, which we calculated in the previous slide, which is x plus 1 whole square divided by 2. This will be minus 2x, and this is x plus 1 whole square. Now this x square minus 1 can be written as x plus 1 and x minus 1, simple algebraic formula, and this whole square will be as it is, minus 2x into x plus 1 whole square, and we can apply a power both of these terms, that is actually x plus 1 whole square and x minus 1 whole square. Now this x plus 1 whole square will be cancelled out. The required dy by du will become minus 2x divided by x minus 1 whole square. So the next part is differentiate this function with respect to this one. Again a simple exercise. I think you must solve this question yourself. An easy exercise for you people. Simply by giving a name to the first function, which is ax plus b divided by cx plus d. A notable point is here only this a, b, c and d will behave as a constant. We have only a variable which is x. So when we will go on applying derivative, the derivative of b will be 0, and similarly a will be a constant term, so come out to the derivative. Derivative will apply only on x. So similarly here, derivative of d will be 0 because of constant term, and derivative of c will be come out to the derivative. Derivative will apply only on x. So applying these derivatives, we have our dy by dx ad minus bc divided by cx plus d whole square. And similarly, when we apply derivative on the second function, which is named by u, ax square plus b, ax square plus d. So differentiating with respect to x, applying derivative by using quotient theorem, we have this du by dx, which is 2ax d minus b ax square plus d whole square. So by using chain rule, dy by du, here dxy by dx and dx by du, putting the values of both of these two derivatives, we have ad minus bc cx plus d whole square, which is actually dy by dx, and this ax square plus d whole square 2ax d minus b, which we calculated in our previous slide, that is actually du by dx. But here in the requirement of chain rule, we have dx by du, so this is actually a reciprocal of our du by dx. So the final result, which is required dy by du, is equal to ad minus bc 2ax cx plus d whole square d minus b. And then last part of this question is differentiating x square plus 1 divided by x square minus 1 with respect to x cube. Again a simple question, just giving a name to this one which is supposed y and this one which is supposed to be u, and differentiating separately, then using chain rule find dy by du. So let y is equal to x square plus 1 divided by x square minus 1. Differentiate with respect to x, as y is the function of x, so we have to calculate dy by dx from here. Again by using our quotient theorem, this x square minus 1 will be as it is, derivative of x square plus 1 is 2x, minus this x square plus 1 as it is, and derivative of x square minus 1 will be 2x. Taking 2x as a common factor, we have x square minus 1 and this minus x square minus 1. This will be cancelled out. We have only 2x into minus 2, x square minus 1 whole square. So finally dy by dx will be minus 4x whole divided by x square minus 1 whole square. And now giving a name to the x cube, which is supposed u, let u is equal to x cube, differentiating with respect to x, and du by dx. By applying derivative on x cube and using our power theorem, that will become actually 3x square. So using chain rule, by using chain rule, we have this one is actually dy by du, not dx by du, because we have given a name first function to the y and we have to form dy by du. So by using chain rule, that is actually dy by dx and dx by du. So dy by du, that is actually dy by du, and dy by dx is minus 4x divided by x square minus 1 whole square into the reciprocal, which is 1 over 3x square of du by dx. So again this one is actually dy by du. So the final result is minus 4x and 3x square into x square minus 1 whole square. So that is actually the explanation of parametric functions, or a combination of function. If we have one function and then differentiate with respect to another function, so just giving a name to both of the functions and calculate a derivative both functions separately, then using chain rule, and will calculate our required derivative of first function with respect to another function.